to the 9th online lecture of the lecture series on science and engineering research leading to innovation, entrepreneurship and scholarship, which is being organized jointly by CSIR, Indian Institute of Chemical Technology and IEEE PES IAS PELS Hyderabad Joint Chapter, IEEE Guntur and IEEE Anantapuramu subsections. The series is featuring talks by distinguished speakers on diverse topics to commemorate the contribution of scientists, researchers, technologists, and entrepreneurs as we celebrate Azadi Ki Amrit Mahotsav, the 75 years of Indian independence. I am Benia Zara Begum, project scientist at CSIR-IICT, your host for today's online lecture on blockchain, a disruptive technology for security beyond cryptocurrency. This is a subject in which we all will be deeply interested. The major reason is blockchain is the latest disruptive innovation that has caught scholars and stakeholders' attention. It is the underlying technology for Bitcoin and other digital currencies. Stakeholders like developers, entrepreneurs, and technology enthusiasts claim blockchain has the potential to reconfigure the contemporary economic, legal, political, and cultural landscape. There are tremendous opportunities in this disruptive technology, and the revolution in this space has just begun. In one of our earlier lecture series, Dr. B.K. Murthy from the Ministry of Electronics and Information Technology has talked about the proposed national strategies on how to embrace blockchain technology. In today's lecture, our invited speaker shall cover the challenges ahead and opportunities in this fundamental technology that is all set to revolutionize our digital world. With this, we formally begin today's session. I request Dr. S.V.N. Lalita, Chairman IEEE Guntur subsection, to give her welcome address and opening remarks. Dr. Lalita, please.
Thank you, Dr. Benash. Am I audible? At the outset, it's very fortunate that we are able to conduct this lecture series with eminent people. I would like to welcome today's resource person, Dr. Naveen Chilamkurti. Thank you very much, sir, for accepting our invitation on behalf of the IEEE Power and Energy Society, IEEE Hyderabad section, and IEEE Guntur subsection and Anantapuram section. We welcome all the participants. We had a very interesting lecture about the blockchain technologies, as Madam has rightly pointed out, and we are really curious to know about what are the cybersecurity issues. There were many questions related to the cybersecurity aspects when this blockchain is going to come into a real total common man also. Thank you very much, sir. Madam, over to you.
Thank you, Madam.
Thank you.
It's a great pleasure for me to introduce our today's speaker, Professor Naveen Chilamkurti from La Trobe University, Melbourne, Australia, to all our attendees. Professor Naveen is currently the head of the cybersecurity discipline at La Trobe University. Professor Naveen serves as the technical editor of the highly ranked IEEE Wireless Communications magazine and IEEE Transactions on Vehicular Technology. He has published more than 320 journal and conference papers, including IEEE and ACM transactions. He is active in editing and authoring 9 books with Elsevier, Springer, IGI Global, and Nova Publishers. He has successfully attracted 20 research grants since 2000 to support PhD scholarships, fellowships, and travel grants for research collaboration. In 2012 and again in 2018, he was awarded a research fellowship to work with IIT Kanpur and IIT Hyderabad. Professor Naveen successfully secured 24 competitive grants from various sources, including SmartSat CRC, Data 61 CSIRO, Defence Science Institute, Australian Academy of Science, and Optus Telecommunication. He is also a guest editor for various high impact international journals. Since 2010, Professor Naveen has contributed to 100 special issues in various international journals, including IEEE and Elsevier journals. His current research areas include cybersecurity, IoT, anomaly detection in IoT, Internet of Medical Things, wireless security, federated learning in IoT, wireless media, and wireless sensor network. I welcome our today's invited speaker, Professor Naveen Chilamkurti. Sir, the floor is all yours.
Oh, thank you very much. Thank you for the introduction. I think it's a long one, but I think, look, I'm still learning a lot of things here. Thank you for your invite first. It's been a great pleasure. Both places are well connected to me. As I said, I grown up in Hyderabad and I studied in Guntur. So, it's a very sort of going back memories. I'll share my screen. Is it okay? So, as I said before, blockchain is really coming up, to be the disruptive technology in 2020. Especially last 2 years is really busy for blockchain. I'll show you my. So we'll discuss pretty much general, basic sort of a foundation of blockchain. Then slowly I'll take it to further. What are the applications, especially security with the blockchain? What things can be done. So with that, I'll try to. You had to tell me whether you can see.
Yes, sir. Yes, so your screen is visible and you are also audible and visible.
Okay, excellent. So look, I think one of the fundamental sort of generation-wise, I mean, it's been there for humans. Basically, human sort of a building pillar is trust. So we trust our friends, we make friends, we trust our friends, we do a lot of things with them, we borrow things from them, we exchange some money with them, a lot of things will happen. And these are all based on fundamental sort of a human logic, I call, as trust. And these days, this is where the technology comes into picture. That's where it's lacking. A lot of technologies are there, but they lack trust mechanism. So in 2008, the new technology, blockchain, really initially, a lot of people know that as a Bitcoin in 2008. I'll give a brief introduction, but that's the background I'm actually talking about today. It's all about trust. So what is the technology? How we can trust a technology? How we can trust a transaction? How we can trust something saying that, look, if this happens on this network, you can close your eyes and say this is trustworthy. This is an integral part of the network, and you can 100% either transfer money or trust the mechanism. So blockchain is that kind of mechanism. So I'll go to the history also. I'll slowly explain what is that coming from, where it's coming from, and how it has actually evolved from a very small concept to it's going to become a sort of a big sort of a backbone for a lot of technologies coming in future. So with that, I'll go to that one. So what is blockchain? And why do we need the blockchain? There are a lot of technologies. So the first question we ask is why we need this one, why we need that one. So one of the question I ask is what is the requirement, why we need a blockchain. So blockchain is required to basically, it will have a great impact in the next decade. As I said, let's debate that one. And the underlying technology, as a lot of people know before, is the Bitcoin. Remember, Bitcoin is one of the application of blockchain. Bitcoin is not the overarching mechanism. It's only a cryptocurrency. It's only part of blockchain. So that's just, I want to make it very clear. And using blockchain, I'll show you some examples. Even in government, I think I'm sure you heard before, there are presentations there, how we are actually converting our mechanisms to most trustable. See, a lot of people don't do things because they don't trust technology, basically. So this, I hope, will make them change their mind, and even business, this one. So coming to that, I'll give you very simple examples why we need a blockchain. So, and all these days, I mean, I'm sure in India, in many countries, we depend on someone. There is some sort of middle person for anything. Like go to a bank, for example, you want to send a money to your overseas. You have to give the money in local currency. They will convert. They will, of course, they'll take commission out of it, because the commission goes to the third person. There is an entity there who is authorized for a foreign exchange. They will convert, they will send it to a different person, central person, they will convert. So there is a lot of layers of mechanism to send money from one place to other place, especially if you're in a different country. So this is where the basic logic is. Why we had to use this, so many people, why we had to pay money to actually transfer. It's just between understanding between two people. Why can't we do something like that? So this is the logic behind it. So today's scenario is we depend on a lot of central entities. Bank has headquarters, every organization has headquarters. Any small item to approve has to go through headquarters. A lot of processing, a lot of paperwork, can take ages. Sometimes can take weeks, months to get some approvals. So this is the where things are very. Even though technology we are using this these days, even though we have technology, but approval process will take a lot of, because of sort of bureaucracy, sort of organizational structure. It can take a long time. So this is where the blockchain comes into picture. It can remove the middleman also. And because of this, a lot of people are missing out. See, the easiness is not there. You had to go through different channels to access different services. So a lot of people are missing on this digital currency also. And paperwork, physical distance can do a lot of complex and long transactions of record keeping. You can go to a lot of, I mean, my memory is a lot of, especially government organizations will have a huge, sort of big buildings, because they have to keep a lot of records, physical records. So they have a lot of storerooms because they have to keep a lot of records. So I think it will be a thing of the past. And I know Telangana government is actually working on that. Various, they remove all the paper tracing, and a lot of things will be digitalized, as you've already seen with Aadhaar and other, racial technologies. So a very important one, underlying mechanism is privacy. This is really important because people don't trust. For example, you take something, your digital identity, you give it to someone, they may misuse. Like, we don't know what they're doing, who is actually storing the credit card, who is actually accessing this information. So privacy is really important. So we can address privacy also through the blockchain. So that's a trend, that's a context we are actually talking about, the blockchain. So coming to this, as I said before, blockchain, a lot of people don't realize what is blockchain is, but they know what is a Bitcoin is. Of course, a lot of people invest in Bitcoins, so they know what it is. They may know, basically it's a digital currency in there. Satoshi Nakamoto in 2009 from Japan has actually developed this blockchain. The first application is Bitcoin. He called it as a Bitcoin. But remember, 2005, he started working on this decentralization mechanism. He was also fed up with a lot of layers of mechanisms between. So he said, why can't person X and Y communicate to each other? Why can't they do their transactions? And why can't they actually do processing by themselves? Why we had to rely on other ones? Why do we need to pay commission? So this is the what he was thinking before. And he established the trust and transaction process, very basic fundamental blockchain. That's the very foundation of blockchain, roughly in 2009. And it came as a Bitcoin. And of course, I'll give you a very simple scenario to just make you understand what is a blockchain is and why we need a blockchain. But I can show you hundreds of examples where this is. For example, two friends, very close friends, Peter and Jack. Peter lives in USA, Jack lives in Italy. So Peter wants to send some money, like a gift money to Jack. So what he has to do is, Peter is in USA, so he has advanced technologies there. Go to a bank, give his US dollars, for example, $100, and say, look, send it $100 to my friend Jack in Italy. So what the bank does is, bank send to a agency called SIFT. There's a agency, and the SIFT will actually, it's a global agency. It will convert Peter's $100 into local currency. It will do all the processing, and of course they will charge the customer for that. And then that party will pay Jack in somewhere in Italy. But remember, Italy will also have a SWIFT account, and they will have a local branch in Italy. So they will pay Jack. So there are 3 or 4 layers here before Jack receives. But remember, Peter sent $100, Jack won't receive $100. He may receive about $85 because the rest is gone as a commission. See, remember this one? $15 lost in transaction. As I said, this is only example I think a lot of people will connect with, but don't think this is the only example we can give blockchain. There are a lot of other examples in there. So remember, third person, intermediate third person is the issue here. Now let's remove this middleman. So why can't Peter and Jack talk to each other and they make a consensus, means agreement, and then they can transfer. And that transfer will happen directly between Peter and Jack, and there'll be money. If Peter sends $100, Jack receives exactly $100, no less, no more in there. So this is what the plan is. This is what exactly the blockchain does. Very simple logic, no middle person, no centralized mechanism in there. Very important one. So what is a blockchain? So a blockchain allows untrusted participants to co-create a permanent, immutable, and transparent record. Okay, transactions and processing without a central authority. See, remember the example I gave? There is absolutely no central authority. People can send it to their friend directly, peer-to-peer. The term blockchain and distributed ledger, though blockchain is used more common, but you may see DL. DL is distributed ledger, often used for blockchain also. It's interchangeable. So it's the same concept in there. So remember, blockchain is built on 5 fundamental concepts. Very important one: peer-to-peer, distributed ledger, consensus-based. We'll talk about them in depth anyway. Crypto secured, immutable. Immutable is very simple. Once it is on the blockchain, you can't delete it. You can't change it. Simple. So it's really almost 99.9% impossible to change a data once it is on the blockchain. That's called immutable. So remember these 5 pillars: P2P, distributed ledger, consensus, crypto secure, immutable. And again, we had to go through the evolution. So basically started as a very simple Bitcoin, again, as I said, and those days it's for cash for internet. So we can do transactions on internet using cryptocurrencies, some online, not all of them, some online websites or services will accept cryptocurrency. Nowadays, it's very common. Previously in 2009-10, it's very few of them, but it sort of course, it has actually increased the usage. And of course, in 2009, it's a different scenario. Nowadays, it's pretty common. So the first one is cryptocurrency. That's called blockchain 1. Blockchain 2 is really interesting. They expanded part of the blockchain, and this is called smart contracts. You might have heard this before, and this is part of the blockchain anyway, mechanism, where the blockchain has a program inside it. It's like a live program inside the blockchain, and it's very much automated. Okay, which means it's already it'll automatically do sort of transactions. It'll check the policies based on your sort of, for example, take one very simple example. I still remember a registration of the vehicle has to be done every year, 2 years, whatever the period is. So what it happens is you enter a system. Sorry, I lost my this one. I'll do it again.
Yes, sir. Now it's visible. We have to reach to that slide, the slide number.
Yes, I'll also change my okay.
Yes, sir.
I think it changed my appearance also. Let me try, sorry. It's okay. I think I'm actually abstracting the PowerPoints. Yep, that's better. All right. Okay, resume. I think we are just a little bit, but yeah. So smart contracts actually a live program inside the blockchain. So it automatically verifies. For example, you want to re-register your car again after 3 years. It will check some conditions. You have all the certificates. You have roadworthy certificate. It automatically does it. Just a click of a button. You don't have to go through the process again and again. It's all automated. And recently, a lot of the lawyers actually using this for contract purpose, to initiate contracts, some sort of legal contracts and things like that. So basically, it's a part of the blockchain, and you can see a lot of applications basically. So it's part of a program running inside the blockchain in there. So coming to the blockchain 3 is decentralized applications. We call DApps. Basically, your structure is such a way that nothing is centralized. Everything is distributed. Your storage, processing, everything will be distributed among your nodes, peer nodes. Nothing is centralized. That's called DApps. Ethereum is one of the example in there. Industry 4. I think someone is actually controlling my.
So is it okay now?
Really, I think let me try.
Yeah.
I think it's.
So here we have the first slide.
Okay. Yeah. Okay. So now it is okay. Yeah.
Yes, sir.
Okay. Let me go back to that. So smart contracts, blockchain 2, blockchain 3 is decentralized apps. We call DApps. Blockchain 4. I'm sure you must have heard industry 4. Now is industry 5 already. The evolution is basically a lot of things will be automized. As you know, as a supply chain, especially warehouses, completely automized. There's a lot of automation in every industry, almost every industry. So that's part of the blockchain also. So that's a blockchain 4 application. Now, this is the critical part. Though I put this into one slide, it is really difficult to know exactly how blockchain works. What is the mechanism? Why it is better? There are a lot of other steps, but let me explain you in a very simple this one. Again, there are a lot of details missing, but ask me if you need details in there. So someone created a transaction. We'll go by step. Someone created a transaction. So that's the first a user created a transaction, and you sign it by a private or public key depending on your transaction. The keys. Keys are nothing but your identity in there. And then that transaction goes to the network. So the network is we're calling a blockchain network. It's nothing but a group of nodes. So for example, take 10 nodes together, we form a blockchain. So we know each other peer-to-peer, and we can communicate peer-to-peer also. And what is the mechanism? Very important one is, so for example, I want to send money to my friend who is in the network, and that is a transaction. More than one node requires to verify the transactions. For example, if there is a 10 nodes in the system on this blockchain, at least 6 of them, this can vary, at least 6 of them has to agree that I can send money to, I have a bank balance, and I'm a trustworthy, and I can send this money, whatever amount, $100, to my friend in the same network. They had to authorize. So they had to verify. That's called verification. This mechanism is also called consensus. So we all agree, majority agree. Just like your voting. Voting happens, people will vote for a particular candidate, the majority will win. So basically it's like a voting. So again, there are a lot of protocols, a lot of mechanisms to verify that. But just remember, the majority will have. So if the majority agrees that I can send money, I have account, I have trustworthy, I'm doing transactions, this transaction is legitimate, they can approve. If they approve, this transaction will be added. So the transaction is valid. So the transaction will be added to the network or the node, and it will be propagated to everyone in the network saying, okay, I transferred $100 to, for example, Jack transferred $100 to Peter, or Peter transferred to this one. So both will be, both parties, not only both parties, everyone will record that Peter sent to Jack $100 will be recorded. Once it is recorded, no one can, even if you own the node, no one can delete that transaction. It's written on the, it's like writing on the rock. Basically, it's written on the rock. No one can change it. No one can change it. If someone tried to change it, the whole links will be lost, and there will be no blockchain. It won't happen. There is no connection between one peer to other peer. Okay. So no one can change the transaction. Once it is done, once it is recorded, nothing will happen. You can't change the transaction. So which means it's written, that's it, permanently written there. So how it works, as I said, is a little bit hard to understand in one slide, but the technology behind is I'll try to summarize it. It has a hash value. Hash is a one-way sort of a, I'm sure you know the cryptography. The background is it goes with it's like a one-way. Once you have a hash value, you can't go back. It's only a one-way transaction. So the hash value will be added to a nonce. Nonce is a random number, and a new hash value will be calculated by miners. Who are these miners? Miners will miners will calculate new hash value based on the previous hash value and the new transaction and nonce. See how the integration of these three parts: previous hash value, new transaction, and nonce value. So it's strongly bonded, basically these three. So any change or any attack or anyone trying to change this one will be easily identified, because it's like a strong bond between these two. Any changes, because it's so much interlinked, you can't change it. Basically, it won't be possible. Well, technically, it's hard. even if you try, it's very, very hard. If you have a supercomputer, you can break a lot of crypto algorithms. Yes, it is possible, but very, very, very unlikely in there. So these three built together will form a new hash, and that hash will be used as a new pointer to the next value, next block. And remember, I was talking about consensus where out of 10, at least 6 has to agree that Jack has to, or Peter can send money to Jack, or vice versa, or between two people. They had to agree that this is true, this is a genuine transaction. We know both Jack and Peter, and they are genuine people. The transaction is true, legitimate. To do that, there are algorithms for that. It's very simple to say, just consensus, but hard to implement. So for that, there are algorithms there. We call this as consensus algorithm, and there are a wide variety of type of consensus. You can prove that your consensus is correct using a proof of deposit, proof of work, proof of stake, proof of time, importance, capacity, activity, storage, any one of them. It's a proof. It's a proof based. This one consensus always will be very difficult because we might not sure what type of consensus, and this consensus should be foolproof. So that's why it's called proof of stake, proof of work, proof of capacity, proof of work. You has to justify. You worked on it. You are genuine. Then you can vote. That's your consensus. Your vote will be valid. It's like you're showing your ID, because there's no one to verify here. There's no third party here. Remember, there is no one to verify. There's no central system. Everyone is independent. Everyone is peer to peer. So there should be some consensus mechanism to say that, yep, this vote is, sort of genuine. This consensus is genuine, and you can actually, go ahead with this transaction. Okay, very important one. So there are a lot of built-in mechanisms to verify your vote or your consensus in there. So of course, built-in mechanism like smart contracts are there, well-written codes inside the blockchain, which will completely pay no paperwork here. No one signs, no one authorizes, everything will be done automatically based on some legal terms or some sort of policies, or whatever policies it is. You can actually build into the system or a programming way. So it becomes very simple to, for example, to sort of a renewal registration or do some sort of property renewal, taxes, everything will become very, very much automated process. There are three types of blockchains: permissionless, hybrid, permissioned. Obviously, open access. That's most of the. Unfortunately, most of them are permissioned, which is restricted access, and some of them, close to 34%, are open access. And in the middle, there is a hybrid. So part of the blockchain is permissionless, part of the blockchain is permissioned, means restricted. So open access, restricted, combined together, we call as a hybrid. There are some United Nations hybrid models where the UN uses some sort of hybrid model for a blockchain to store their data, various data. There are open access Ethereums and other things. There are some banks which will follow the restricted access, basically. So there are very wide varieties of applications for these blockchains in there. So don't think blockchain is just for Bitcoin. You can see a lot of applications will use blockchain, data management, P2P, currencies, especially cross-border payment. You don't need to carry US dollars for everywhere because that's mostly common used currency. You have a PayPal or something, you can use anywhere, any currency. A lot of sort of digital wallet is valid. So it becomes more cross-border payment. Especially smart contracts will become sort of integrated with the supply chains, legal, commercial, insurance, especially, so many things. They use smart contracts for verification, especially. One of the first one to sort of embrace the blockchain is health system. I'm not sure. I think India also started doing this. Australia has a digital healthcare, which means when we visit a doctor, a general doctor, they won't give any sort of paperwork for us. Any, for example, you do a test, a blood test or an X-ray, everything is digitalized. So when you take a blood test or something, the digitalized form report will go to the doctor and it will be stored under the My Health. My Health is a Australian health sort of a system. It will be stored there. So which means I go to a different city or place. I need some, go to a hospital or something in there. They can use the system directly. It's like a cloud. So they use my report or my, background. Everything will be available for them easily. So they don't need to contact my GP or general practitioner, get all the information, what type of blood or what conditions I have. Everything will be simply. And a lot of people ask one question saying how secure it is. Again, it is in development. My Health is a living proof. Basically, a lot of things are on My Health now, and our records are easily accessible anywhere from any hospital or any other providers. So the health system is one of the first one to embrace the blockchain. Reason being, it's secure. It can be secured and it is tamper free. No one can actually tamper with the system. It's very much tamper free. That's what immutable is, integrity. So you can see the structure here. There are a lot of components though, but it works. And see the architecture here. It includes a lot of providers also. It includes pharmacies, health providers, physiotherapies, other associated allied health. Your records, your government payment records, everything integrated. So they are all connected. If you had to claim something, you just press one button and it'll be, you can claim your health benefits if you have any. So very simple system, but the background is the blockchain is guarding this system in there. The other 20, I think, especially, of course, these days with pandemic, everything is online. There is a big, I think about 300% increase in the online, supply chain. Basically, people are buying online most of the things because they can't visit stores and things. I'm not sure you heard, Melbourne is rated as one of the most lockdown city in the world. So obviously, we can't go outside. So we order a lot of things from online, and there is a very good supply chain underneath, and this supply chain is guarded by the blockchain. So see if you see the presentation here, the records are pretty much blockchain records, and there will be some smart contracts built in this one. For example, if you order very much special items, for example, if you order a cheese from France, and the cheese has to be stored in a particular temperature all the way through. It can't drop below that temperature. If that drops, the cheese will not be as good as before. So generally, the temperature will be controlled. All the logistics will have some temperature control, and it will be traceable through the blockchains. So we know exactly how much temperature is actually at one point, at every point of the logistical chain, supply chain. So very simple example, but you can trace it. When it is coming, you can really trace what is going on, the authenticity of the supplier, you can trace it, who is sending, because they're all under the blockchain, which means no one can tamper with this. So it's I would think it's very good example in there. But don't think that's only examples we have. We actually found out that there are so many other areas they can use. Real estate, I'll show you in a minute where they use for real estate. Credit history, supply chain, voting, cybersecurity, gun safety, education, so many things. Banking, especially banking, and IoTs especially. So let's see what are the major implications. So this survey is did in, I think PwC, Price Cooper Waters did in 2018, 3 years old. But I think it's relevant because you can see who is actually using blockchain currently, that 2018. So 46% of financial services, see 46%, finance, banking, and any other financial services, stock exchange, various other financial services, they are using blockchain. Almost, I'm sure it will be more than 50% now. So they are the first ones to use blockchain for their transactions because obviously money is involved, monetary transactions involved. With the world is becoming so close with the transactions, online websites, you order for various foreign currencies and so much transactions going on. There is a lot of loopholes. So they want to make sure that they're all tamper free and obviously immutable. Once it is entering the transaction, you can't change them. So obviously that's a financial. Other industries are products and manufacturing, energy, healthcare. The government is actually using, I'll show you in the next slide, the governments, how they're actually using blockchains. I'm sure this is not a surprise to you all. So I just copied from your the government website, Telangana. So they use blockchain for chit fund, verifying student credentials, land records, very important. Dharani is a very recent one, if I'm right. And Srinidhi is also pretty much credit corporation based, I think small loans, if I'm right, that sort of thing. So they're using a lot of things, a lot of applications based on blockchain. So this is exactly from the government website. If you want to go to that website, blockchain district. District is the blockchain district, Telangana government.in. That's the one. And they're pretty much well into applications. And remember, the first one is really, I think, I know chit funds are very ad hoc before. I remember there are some private companies which used to run this chit fund before. But now chit funds are a very basic, fundamental money transaction, money sort of, I would say savings, companies, small, very small companies, but now they made it very much like a formal one. It's called T-Chits project. And I think it's about 200 crores of money per month is being transacted or used. And you can see the various sort of description in there. So it's not too far. I'm sure you will feel or you will actually encounter blockchain in your daily life pretty much coming couple of years. You will again, some may be able to find it out, some may be not able to find it out. Like, for example, I'm sure you'll be having some land records and Dharani. People use it, but they don't realize what is the architecture behind it. And a lot of people are actually signing up for this because they trust this mechanism. Once they know what is the mechanism behind it, they'll trust it. And I think a lot of people will actually enroll in this or use this facilities or the products basically. So really, I think I'm only highlighting 5 of them, but the website highlights a lot of other applications also. So do have a look, very important one. And country-wise, we are, of course, US and UK are the major sort of front runners in this implementing blockchains. And India is not too far. Actually, India will pick up pretty fast because of the volume, population, and applications. I'm sure India will pick up pretty soon, applying the blockchain ledgers. So coming to my main points here. So that's about blockchain. What is that connected to the security? How we can secure communications, how we can secure transactions, how we can secure a network using blockchain. Very important. I'm sure people working in this area, blockchain or security will know about CIA. It's nothing to do with US agency. It's called confidentiality, integrity, and availability. So like a pillars, strong pillars for your cybersecurity. So confidentiality is about network access, disclosure of data. Integrity is immutability, means how do you know actually the data you got is truth or not, the correct data or not. If someone might have modified in the middle or not. So that's called integrity. So obviously blockchain will give you that integrity, assurance basically because of the immutability. Availability, very important. See, it's not that I'm storing all my data, all my health records on the system. The system should be available 24/7. For example, there is a need, a very urgent need for particular data, a health record, and it should be available within given time. And if it is not available, then it's a big problem. So availability is really important. So you had to consider CIA before any secure architecture. Very much you follow that rules, CIA rules for any system. So in I think the wireless is becoming very popular. You can access your network, wireless network, most of the major points, railways, hotels, and everywhere. So, but unfortunately, at this stage, they're all based on PKI, which is called public key infrastructure. But in future, we'll be using a different structure called keyless signature infrastructure. We call it as KSI, where you don't need to carry any key. It's all in the blockchain and use a hash function cryptography to authorize. So everything will be on the blockchain. So accessible, and everything will be accessible anyway. You don't need a PKI system, public key system, and more secure. Obviously, it will be more secure. Passwords. I'm not sure how many know. Cybersecurity, as a cybersecurity person, we always say we discourage text-based passwords. Passwords are the most vulnerable points, I would say, or vectors we call. How many? I mean, you can create passwords as complex as you can, but end of the day, if you can't remember them, it's absolute. So it's becoming absolute anyway. Passwords are becoming absolute. Two-factor authentication is also becoming more popular because it's not only passwords, it's something else associated with that, either SMS or some sort of verification on top of your passwords. But again, passwords are becoming because it's based on human factors, how you remember, and things like that. So again, that will be a very weak point in our cyber threat system. So we want to make passwords as absolute. So blockchain can help you to remove that sort of weak point using some structures in there. Very important one, privacy and security. You can see a lot of things happen on internet, a lot of chats, a lot of things will happen, a lot of personal data will be exchanged. So use blockchain. We can make sure that the data is secure, immutable, and encrypted. So which means anyone can, if they capture the data, they don't understand because it's encrypted in there. And obviously, one of my main research I'm doing on intrusion detection, very important because so much data is coming through. We don't know what is true data, what is false data. We don't know what is actually who's trying to attack us. A lot of vectors involved. So using this system, we can actually putting the data on the blockchain can avoid this intrusion detection because see the normal system here. They can change your logbooks or the log system logs. They can delete them. They can replace them. Hackers can do anything. But once they are in blockchain here, see here, once the data is on the blockchain, no one can delete it, which means they can't delete, they can't amend system log, which means obviously there is no intrusion here. There is no one can join, no one can delete anything. So obviously pretty secured using blockchain here. Now coming to the system again, Bitcoin, one of the major applications. It's one of the major, and it's picking up a lot of pace these days. I mean, I'm sure you read the news saying it doubled, tripled, and people are becoming billionaires, millionaires just by investing in Bitcoin. It is all true because it's varying a lot. People are embracing it. Some countries are actually making it as a legal tender. And I'll talk about this. So it's very common. And how we do that, I think I'm sure you're aware of this digital wallets. You use PayPal, or in India, they use a lot of digital wallets. So to pay for your Uber drive and other services, basically. It's basically between two, for example, Bob is a merchant, Alice is a buyer. You can buy straight away without any bank. You can use your digital wallet coins, the money, without any bank transactions. There is no bank involved in that. This is a straight transaction between the user, customer, and basically the seller in this one. So there is a process goes on in the blockchain, and the receiver will receive the money without any bank, without any sort of commission in this one. Let me give a little bit of, I would cross this pretty quickly. Let me give you a bit brief cryptocurrency stack. By the way, Bitcoin is not the only one, not the only cryptocurrency. You know how many? There are 4,000 cryptocurrencies existing in 2021. 4,000, small to large. Of course, people may know Bitcoin, they may know Ethereum, Litecoin, and some popular ones. And this is a really interesting. See here, this point. There are ATMs. You can actually, get your Bitcoins in some countries, not in India, but some other countries. So the current ATMs are about 14,915 ATMs around the world, where you can actually transact with a Bitcoin. We can actually buy a Bitcoin, or take from your account if you want to. It's just a transaction, and the users are growing. For example, I think about 68 million digital currency users in 2021. But of course, the transaction is about 300 billion, for especially in Europe. So there are a lot of projects going on in US, Europe, UK, and of course, I think you heard this news recently. El Salvador, a South American country, and Peru had made Bitcoin as their sort of digital currency, as their legal tender. Means you can actually go to a shop and use your cryptocurrency to buy groceries and things like that. So you can see there's a big market for this cryptocurrency. And I want to show you of course, every good thing will come with a bad effect. Obviously, we see so many malwares coming with the cryptocurrency. In March last year, we saw about 667 million new cryptocurrency malwares. Very simple ones. You'll get a text saying that you've been awarded a Bitcoin valued at $2,000. Just claim it. Click on this link, and you can claim your $2,000 worth, USD dollars worth of crypto, the Bitcoin or cryptocurrency. Very simple. A lot of people think, oh, this is, because they invested some before, they may think it's legitimate. They click on this. A lot of malwares with that because it's a talk of the town. A lot of people are looking at it. This is pretty old, but I can tell you that the market rate is actually changing every day. People bought. I know people bought with hundreds, just a couple of hundred before. Now it is 4,000. It could be different today. It's just varies depending on who says what. Some of the big companies, they say, oh, Bitcoin is we are going to use Bitcoin. Suddenly the Bitcoin value will go, sort of rooftop. Some will say some government actually banned Bitcoin, then the Bitcoin value will come down. There are so many factors. So this slide will tell you what are the sort of big Bitcoin is a big see the volume, basically $106 billion volume, but this is again 2018. So you can see there's a lot of difference in there. And you can see a lot of difference in your internet also. There is a Web 3.0 coming based on blockchain, which is already implemented in some of the areas. Like I know some of the countries are actually trialing this Web 3.0. What is the difference is basically it's all decentralized. There is no server, client based. It's all, everyone is server, everyone is a client. So it's all peer-to-peer network. And you'll see a lot of sort of decentralization mechanism, and you'll see a lot of data will be stored at your place or on your cloud, but it will be owned by you, not Google or not Facebook or someone else. So it's more controlled by you, by the user rather than companies, because now we are using a server based Web 2.0. So this will convert basically into peer-to-peer. So it will be the next generation in there. So as I mentioned before, I'm sure law is actually using smart contracts. Not only law, supply chain, any government organization where there is a need for verification, it can be done online pretty much using smart contract in there. Again, as I said, some of the countries actually use blockchain as their this one. And I can see a lot of growth in secure IoT also. Blockchain technology can, because data is secure and people can use IoTs. As you know, IoTs are picking up again pace because of the usage. A lot of people are using, and cost wise very cheap, starting from agriculture, health, industries like mining, industry, automation, all based on IoTs. This is small devices basically. And if you know what DNS is, domain name service, the reason I said is one of the major attack in, I think 10 years ago happened on the DNS. DNS is basically a link, a database. And if you can attack the database, change the mapping, everything will be gone. So that is actually, it is becoming more secure now. It's called secure DNS, SDNS in there, using blockchain. And of course, preventing false data injection, pretty important for any data collection, large volume of data is there. I know last couple of years, DARPA, which is a defense academy in USA, actually trialing their applications using blockchain. So they're especially for interference basically. So there are a lot of applications well planned. But of course, as I said, everything will come with a sort of I would say, a hitch. So obstacles. What we found is, though it is easy to say, I can say blockchain is really good, everyone can implement it. It's not true. It's very much computational, sort of intensive, and you need a lot of computational sort of computing background. It's difficult to understand. Regulating smart contracts are difficult, and there is no standard technology, no standard body at this stage. So blockchain's implementation will be a little bit slow compared to what we started with Bitcoin and other things. But I hope it will be pretty soon. With that, I conclude my this one talk. I'm happy to take some questions. Thank you.
Thank you, Professor Naveen. It was a very nice presentation from your end. We'll take up questions now. We are having attendees from YouTube also and from Facebook. YouTube attendees, they can post their questions in the YouTube chat section. And we will take up the questions to Professor Naveen one by one. Yes, any questions from the MS team? Yes, Dr. NVS. You are muted. Okay. Yes, no.
Thank you, Professor Naveen Chilamkurti. Nice to have you on our platform. Okay. And it's also nice to know that you grew up at the city of Hyderabad. Yeah, so that makes, things, explain things in perspective of the Indian context, like you talked about the Dharani network and other things. Now, my question is, do you draw any parallels to the Hawala network that we have and the blockchain, the way it is being done? An
Oh,
interesting
yes.
question. Right?
Yeah. Yeah, good question. I said, yes, definitely. See, one of the, we call is a money laundering. Basically, the term we call ML, money laundering. It's a very big network. And I was about to tell about the chit funds also. Chit fund is also sort of, well, I won't say bad and good and bad, but it's also evolved from sort of need for a trusted person or trusted mechanism. And Indian government, I know a couple of years ago, is sort of first thing they said about Bitcoin is basically they are scared to death because once it is open, because it's virtual, the Hawala market will be the peak because, for example, two entities has to send money without any bank or without any other authority. You can imagine how things will be. It's just black money will be everywhere. Like it's just everyone will convert into sort of a bitcoins. Everyone will transact and send money to overseas, and they want to control all this. And the first thing they said about Bitcoin is no more Bitcoin as a legal tender in India. So obviously there is a reason. This is a money laundering is the one of the biggest constraint they have. They said can't do it. I mean, they can't control this mechanism. Even with a mechanism like blockchain, see, end of the day, someone has to enter this data, right? And if they don't do it properly, the system can be corrupt. Because blockchain is not by itself not a AI or something. It just takes valid input from you and make it secure. But if it is not, the validated data is not coming from a valid person or entity, there is no guarantee. We can't guarantee that. So this system, exactly. This is definitely will. Again, they are rethinking that how to implement, but I don't think there is an easy solution for us.
Thank you.
Another point that
Okay, yes, yes.
any other questions? Shall I come in, Benias?
Yes, sir. You can take.
Another point that I was trying to bring out is like at the back end, a lot of computations that are happening, and it's very
NVS, sir. Sir, kindly check your network. Yeah, now, yes, you can continue with your question, please.
Yeah, I hope I'm audible. What I was telling is, this is very computationally intensive. In back end, there are a lot of complicated algorithms that run, and you need a good amount of good big servers to cater that. Okay. So for an ordinary user, is there any front end which makes it more user friendly for all transactions?
Good question.
Who would do that?
Yeah. No, very good question. So everyone is saying, look, I also said it's very computationally high, but how people can use it? That's a question. So we have some projects going on, funded projects by various organizations to make it lightweight. So lightweight is where we are trying to reduce the computational complexity by using different algorithms to make it better and easily sort of computable compared to the actual one, because the actual Bitcoin is really computationally very high. So we are actually developing some lightweight protocols only for this purpose, blockchain. But I wouldn't say a common man will be able to use on the PC. I think it's a bit of a couple of years time, not at this stage. Hope that answers your question there. But definitely that is true. It's a highly computational complexity.
Thank you, Professor. There is one question from the MS team in the chat section. What is zero knowledge proof and Byzantine fault tolerance in blockchain security by Shiva Prashant?
Look, I think I'm not sure about the first one, but definitely Byzantine is well known. It's a consensus mechanism. Basically, it's coming from old age Byzantine general. Whereas how to reach a consensus is really important. When to attack, how based on what vectors we can attack. This is a consensus mechanism. But what is the other? Is this a zero? I'm not sure about that actually, but I heard of this zero proof, this one, but unfortunately I didn't do any work on that.
Yeah, Shiva Prashant, are you there? You can talk to sir about this. Yeah, Shiva Prashant.
Yes, sir. Good afternoon. Good morning, sir. This is Shiva Prashant. Yes, ma'am. Am I audible, madam?
Yes, you are audible.
Yeah. Good afternoon, sir. Myself, Shiva Prashant, student of Dr. NVS, sir. So I had this zero knowledge proof in cryptography and security in blockchain terminology, sir. So I would like to have information about it. That's why I just posed that question, sir.
Yeah, so remember I was talking about consensus mechanism where at least more than 50%, means 60%, 70% of the nodes has to agree on for a particular transaction. This is where they use this Byzantine rules. So how to make sure this is a true valid consensus. And you can use various, as I think I remember about a major one are about 12 to 15 major algorithms available. You can use them as for the consensus in there. If you want to go technical, I think we can go technical, but I think I'm happy to send you some information on that.
Shiva Prashant, you are satisfied with the sir's answer, and
yes,
you can mail sir so that he can provide you some more information in this context. Sir, I have a question from my end. You have discussed about, first question is, you have discussed about the types of blockchain, permissionless, hybrid and permissioned. In which stages, because these are all a part of a blockchain. So which stage of that blockchain architecture we have permissionless, which one is permission, and which one is the hybrid part?
Okay, so these are not parts of the blockchain, these are types of blockchain.
So we can have only one type of blockchain at a time, or we can have a hybrid?
Look, I think no, I would suggest one because see, the architecture, whole architecture is based on the type. For example, you take a permissionless where the public, so anyone can join the network and the rules will be different. So if you have something like a hybrid, so one part of this, you told that your assumption is right. One part of that will be a public one part of it is a private one, which means public anyone can access, private only authorized users can access.
So my next question is regarding you have discussed about some of the examples from the blockchain, such as the healthcare system, supply chain, and the land records maintenance system. So regarding this healthcare system, you have mentioned about an example that is being already implemented in Australia, health system regarding. So we have a patient record. So it is just like an Aadhaar card, just in India we have. These details are there already in the database, and when a patient wants to visit a doctor, automatically that record can be accessed by that doctor. It just like if I tell about an example in India, if that patient is visiting somewhere in Hyderabad and this person, the record from some X hospital is able to access that record. But if he doesn't get any solution, then he visits to some Delhi or some other place to some well-known doctor and get him or herself treated. So is it just like that?
Definitely. I think you compare really well. You know that Aadhaar is one of the largest secure database in the world. One of the digital secure database in the world. I mean, 130 crore is not a simple database. So my health is not only that. You're right. It stores all my data. It stores all my sort of health record based on various health conditions. But remember, this is a lot of it's a various other allied health also can access this. For example, I go to a medical shop and I don't have any card or something. They just use my name. They can actually, and they can have a prescription. I think there is a prescription. You have to take it to the some medicines are only available through prescription. We don't take prescription. There is a digital one, and he will access through the network, and they will give me the medicine. I don't have to carry. This is a paperless basically, and you can use for a lot of other things also. Some payments, some medical payments. There is a threshold. Hospitals especially use for their records, and it will be really one place for all this health. And good thing is you can use it anywhere. I know UK also had this record, so it's interchangeable. For example, I go to UK, we have sort of understanding with them. I can actually retire there and use my health card there in UK. US also some sort of similar understanding. So it's much more distributed, and it is possible only through blockchain.
Thank you, Professor. Any questions? Yeah. Any questions is there?
Yeah, can I ask something, Naveen?
Yes, sir. Yeah. Yes.
I keep asking a lot of questions. Okay. Again, it is slightly off the the track. If you look at the 70s, when oil was being largely used, the government of US, they sensed what potential it has, and then they introduced this concept of petrodollars. And that has actually, because all the oil is now at that point of time was different denominations, different currencies, but then they made it an unwritten rule that it has to be done only in US dollars, petrodollars. Okay. So that has made the nation, very, very rich, the US. Now, if there is an early leader in, embracing this Bitcoin, do we have a chance of positioning ourselves, say if India takes a decision, do we have a chance of, replacing the US in the world market?
Look, I think very government actually thinking about this. And as I said, El Salvador is the first one to implement legal. And I know some of the other countries actually thinking to implement this replacing US dollar, because US dollar is the most, it's a common currency for any transactions. Now they are thinking to make a bit sort of similar cryptocurrency as their, but as you know, world is divided into different parts. Some support US dollars, some don't. And there is a lot of, until unless UN actually says, look, we had to come together in some form of agreement. I don't see it's coming because, as you know, there will be winners and losers. So who wins is again, consensus is a big thing. But saying that it started, there is a, sort of a small change here and there. As you know, some of the European countries actually buying their gas and natural gas and petrol through cryptocurrency. Slowly started doing that, but it's not widely used at this stage. But I can see in the vision is definitely we can, but there'll be a lot of hurdles because again, this is a system goes beyond my age, hundreds of years ago, not thousands, but hundreds of years ago. So changing that will be a difficult part. So hopefully that will change.
Sir, we have a question from YouTube attendee. His name is Ashok, Mr. Ashok. he has question how to prevent leakage of taxes at both receiver and sender end, especially in cross-border business transactions. This could also probably be used for moving proceeds of corruption and the hikes. Shall I repeat it again? How to prevent leakage of taxes at both receiver and sender end, especially in cross-border business transactions.
So is it talking about the current system, or he wants to be on the sort of Bitcoin?
It's about the current system only, because the next statement that is followed is this could also probably be used for moving proceeds of corruption and the hikes in prices.
I think maybe if you can rephrase it, he wants to know how Bitcoin or how blockchain can prevent these things.
Oh, yes. Okay, right. Good question there. So see, there are various types of corruption, and the corruption can happen at both sides, sender and receiver. What they do is, for example, if someone is actually sending $100, they'll take commission off, though it's not actually, they don't have to, because it's part of the, for example, there is a understanding between two countries, and the two countries agree tax-free, so you don't have to pay any tax. But for example, the person who is actually in charge here try to do some, sort of again corrupted. He'll say, "Oh, look, this currency is not allowed," and he tried to change that, rule, because it's up to him. There is no guarantee that he's not tampering with anything. So he will tamper and say X is sending only $90 instead of $100. So only $90 will go there, and the other person will say, "Oh, you send $90." From the other side, but actual money you send is $100. But because of the corruption, they can do a lot of things, like in bookkeeping or any transactions you can manipulate. So this will happen now because we all depend on books. See how many registers we use. We sign in the register. We sign on the passbook. If you have passbook in the bank, everything is now on the book. So how easy to change it? How easy to manipulate it? This is what's happening now. So with blockchain, nothing, he can't do anything, because once there is no middle person. So there is no corruption, there is no data leak, there is nothing, only between sender and receiver. That's it. No middle person.
Thank you, Professor. But still, I just have a counter statement I'm giving. We go to many, we have encountered situations like for land registrations. Although everything is very online, but there are people who just to get a signature from their officer, they take that money, and this money is somewhere like under the table, they take the money and they distribute it among themselves. Is there any way to stop this? Despite of having the CCTV cameras, I have observed it, and I was there to see that, oh, this is also happening in such a system. Is there something that blockchain can do?
No. I can guarantee you that no one can replace human touch, because computers are not they don't have any sort of mechanism to think. Whether you're doing something right or wrong, it will follow your instructions basically. What we're trying to do is at least something entered is safe. So people can't manipulate what you enter. See, now, I'm sure there'll be one register at the front office, you have to enter, then it will go to the next boss, he will sign, the next boss, he will sign, everything will go in round and round. Things can definitely, as I said, can go wrong. But now what we are avoiding is that middle person. At least we are honest, the receiver is honest, let's do transaction between these two. But I tell my students all the time, whatever system you have, whatever software, security, all will depend on human nature. The human factor is the most critical in any security. See, for example, you have a big, switch which can stop everything. But if it is not switched on by the human, it won't work. So if it does it, and if it does it in a wrong way, it can go wrong too. So it's basically, at the end of the day, it's all, but at least we can be assured that the data, once it is entered into the system, is secure, which is probably better than nothing.
Thank you, Professor. There is one more question regarding this is in continuation to Shiva Prashant question. Actually, his question was about this zero knowledge proof. So here you have already mentioned in one of your slides regarding this how to prover and a verifier. So how this actually this entire operation happens? Only one person is there to prove the identity. Yes, this statement is true.
So this is talking about the consensus. Oh, now I got this. I think he's talking about zero knowledge protocol.
Yes, sir.
Is it?
Yes.
Okay, right. So it's actually a protocol. It's basically, I think I can see this protocol now, is a method by which one party can prove to the other party. It's like a verification protocol. So we don't know each other. For example, I don't know you. So we have to start something, right? So we start with this zero knowledge. We don't know anything. You don't know about me. I don't know anything about you. Zero knowledge. And then we have to prove ourselves. So this is where how the information will be exchanged. So that is called zero knowledge proof protocol in there. So consensus, coming back to the consensus, very important, very good question here, is, see, it's like out of 10 people in the network blockchain, as I said before, for example, 6 has to agree. But it's easy to say 6 agree. What does that mean? What does that 6 agree means? It can be anything. So there are mechanisms, protocols designed to prove yourself. Okay, I am Naveen. How can I prove? So how can I prove myself? So I had to show my ID. I had to prove that I'm working. I had to prove that I have, my identity. I have something I can show. Okay, so this is proof that I am Naveen. So like that, everyone should prove themselves to vote yourself, saying, okay, look, I prove myself. Can I say yes? Yes, you can say yes because we verified your authenticity using your protocol. Like, what is the protocol? The consensus is based on proof of work. You show that you worked for this. Proof of capacity. You show that you have capacity to be part of this. So some proof has to be there to verify, and my vote is counted. See, when you go to voting, they'll ask your ID. They won't just give you the voting form, right? So think that way. You have to prove yourself. It's not just, see, I'm a registered voter in India, but I never voted, but I'm sure my vote is taken by someone else every time. When I actually went, they said, you already voted. I never voted in my life, but it's already done. Why happening? Because the proof of identity is not properly checked. So this proof will make sure that your authenticity, identity is properly checked. Everyone who's voting is the eligible voter. That's called consensus.
Sir, perhaps we need a system like a biometric. When we go to any polling booth, our eyes should be scanned and verified. Yes, this is the registered, verified voter, and then only our votes will be safe.
But think about it. Think about it. See, this is the big problem we have. Think about it. You can replace anything in your life. You can replace anything. You lost something, you can replace, but you can't replace your bio. So remember, if you lose your bio identity, that's it. You're done. I mean, someone will take your identity basically. So that's why we have sort of reservations on the bio identity. It has to be part of it, but not wholly on that basis.
Thank you, Professor. Is there any questions from the MS teams? Any attendees? Do you have any question? I think there are no more questions. I request Dr. N.V. Satyanarayana for his concluding remarks.
Again, once again, thank you, Professor. That's a wonderful way of telling us what the potential of blockchain technology. But then I think the takeaway from me is while you as a computer scientist and then someone who has been doing research and the whole community can always try to provide something which is very, very secure as far as the computation is concerned. Okay. Then unfortunately, we do not have any control over malfunctions that happen. Like in the case of the Byzantine generals, if one of them lies, habitual liar, I think that we will not be able to counter. But then nevertheless, we'll be able to provide a foolproof, secure system with the blockchain technology as far as possible. Okay, but then beyond that, we need to rely on the genuineness or the sincerity of the human. Okay. So that's the takeaway from me. And another takeaway is this is an upcoming technology. The potential is huge. People look at only as for substitute for cryptocurrency, but then leave aside cryptocurrency, the applications are quite huge, like some of the governments have shown. And if that is taken, if that is done, then I think leaving aside cryptocurrency, that's it, because that is something highly controversial, could be controversial. But then leaving that aside, there are many areas where we can embrace this technology. That's the main takeaway from your talk. Thank you so much, Professor.
Thank you.
Thank you very much. I think thank you for giving this opportunity.
Thank you, Dr. Satyanarayana, for your concluding remarks. Let me propose a vote of thanks. First and foremost, I am grateful to Professor Naveen Chilamkurti for accepting our request to be the invited speaker for the LS series. Thank you, Professor. I would like to thank each and everyone who have joined us today through MS Teams, YouTube, and Facebook. The idea of having this lecture is to commemorate the contribution of my supervisor, Dr. N.V. Satyanarayana, Chief Scientist and Head, Energy and Environmental Engineering, who is superannuating this month. So this LS series is dedicated to him. For placing LS series on such big pedestal, I thank IEEE PES, AS, PELS, Hyderabad Joint Chapter Section, IEEE Guntur subsection, and IEEE Anantapuramu subsections for their spontaneous support. Let me take this opportunity to also thank Professor Harinath Reddy, Professor Y.V. Siva Reddy, and Professor S.V.N. Lalita, the chairpersons of the 3 sections of the IEEE. I express my gratitude to Dr. S. Chandrasekhar, Director of CSIR Indian Institute of Chemical Technology, for his support and encouragement to organize the lecture series. I also thank the organizing committee members, Dr. A.G. Rao, Dr. Venkat Mohan, and Dr. Chandrasekharam of my institute for their guidance. I thank my fellow colleague Sri Raghunarayana for his effort and time in preparing the groundwork for hosting the LS series webpage and for communicating to different platforms about this event. I also thank Sri Radhakrishna, who heads our computer center, and his team for making the lecture available on MS Teams, YouTube, and Facebook platform. Once again, I thank Professor Naveen for joining us today. Before we end today's session, there is an announcement for the next upcoming lecture. The 10th lecture of the LS series is on 22nd October around 3:30 p.m. This is different from the normal schedule. We are having it around 3:30 p.m. This lecture is on a future hydrogen economy, reality or a pipe dream. This talk will be given by Dr. S. Srikant, formerly Director of CSIR NML and outstanding scientist of CSIR. I request you all to visit our webpage www.csir-iict.in/LS series 2021/homepage-start.html to know more about our invited speakers and for brief summary of their topic. I request you all to join for the next lecture on 22nd October around 3:30 p.m. Have a good day. Thank you, Professor Naveen.
Thank you.
It's my great pleasure to meet you today.
It's a pleasure. As I said, I'm very frequent to Hyderabad. I visit a lot. So, yeah, well, yeah. So I think you're on mute.
Yeah, what I was telling is that, please do visit our lab in Institute of Chemical Technology.
Definitely,
It's
yeah.
located very close to your alumnus, Usman University.
Yes.
We have, let's keep this interaction going. Thank you so much.
Sure. Yeah. Thank you very much. Thank you.
Thank you, Professor.